Let's talk about probability. Now, probability is really the study of how probable things are, or the likelihood that certain things will happen. It's pretty useful. But before we get into it, we need to talk about some definitions, and we'll cover a few here and a few later. First, let's talk about what a trial is. A trial is an action or an experiment with outcomes. Say, spinning a spinner. We might land on a 1, 2, 3, 4, 5, etc. An event is actually when something happens. So if I spin the spinner and I get a 5, getting that 5 is the event. Now, a sample space is all of the possible outcomes of an event. So let's say our spinner had 10 spaces, 1 through 10. Our sample space is 1 through 10. So here's an example. Our trial would be rolling a 6-sided die 3 times. The event would be rolling 3, 4, and 5. I could have rolled 4, 5, and 6, and that would be an event, but we're looking for a specific thing, 3, 4, and 5. That's what happens, or that's what we want to happen. And the sample space is all of the different sides on the die, 1 through 6. Now, probability boils down to this right here. Looking at the ways to get what you want, or your desired outcome, over the total ways to get stuff. Let's say we wanted to roll a 6 on a 6-sided die. We wanted to roll a 6. We wanted to get the most numbers we could to roll in Monopoly or something. So we would want to roll 6. So the ways to get what we want, there's one way to roll a 6 on this die. There's just one way to roll that 6. And there are a total of 6 ways to get stuff, right? So there's a total of 6 ways. Therefore, the probability of getting what we want is 1 out of 6. The total ways to get stuff is known as your sample space, and the ways to get what you want might be called our desired event. There are 2 types of probability, theoretical and experimental. Now, theoretical probability is what should happen, what we expect mathematically to happen, so kind of like a mathematical expectation or prediction. Then there's the experimental probability, and that's what actually does happen, so the results of an event. Now, here's an example. Let's say I sit down and I calculate the probability of a thing like flipping a coin and getting heads. Well, I would know that there are 2 sides to that coin, and I would know that the probability of me getting heads can happen one way. So getting heads would be 1 out of 2 times. So I would expect that 1 out of every 2 times I would get heads. Now let's say I rolled that thing 100 times and I counted the number of times I got heads. I would expect, based on a theoretical probability, to get 50 out of 100. But in reality, the experiment doesn't always give you what you want. The theoretical and the experimental don't always match. But the more experiments you do, the closer you get to that theoretical probability. So that if you do 1,000,000 flips of that coin, you're going to get closer and closer to 1/2. The way we calculate theoretical probability is by taking the number of favorable outcomes, let's say rolling the die to get a 6. There's one way to do it. The number of favorable outcomes over the number of possible outcomes. So in rolling a die, there'd be 6 possible outcomes. When it comes to experimental probability, it's the same kind of deal, except we're dealing with something that actually happens. So we say the way to calculate experimental probability is to take the number of times an event occurs, right? If we flipped a coin and we got heads 50 times, we would put that over the total number of times the experiment is done, so 50 out of 100. Let's take a look at a few examples. First example problem. Our solar system's 8 planets, in order of least to greatest distance from the Sun, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Wait a minute, what happened to Pluto? Anyway, you will randomly draw one of the names of the planets and write a report on that planet. What is the theoretical probability that you will select a planet whose distance from the Sun is less than the Earth's? Now, first off, we need to see which of these fit that guideline. So we know that Mercury and Venus, in order of distance from the Sun, those are closer than the Earth. So these are the 2 ways to get what we want, right? A planet whose distance from the Sun is less than the Earth's. So how we would write that is P, and we write a capital P there, and the P stands for probability. This is just a certain kind of notation that we use. The probability of getting Mercury here, or Venus, because we don't have to get both of them, right? We're not going to be able to reach in and draw both names out. We're going to reach in and draw one or the other. So the probability of getting Mercury or Venus. And that's going to be equal to the ways to get what we want, right? Over the total possible ways to get stuff. Now the ways to get what we want, there's 2 ways we can get Mercury or Venus. And the total possible ways to get stuff is 1, 2, 3, 4, 5, 6, 7, 8. So 2/8. And that's the probability of getting Mercury or Venus. We can simplify that, right? Because that's also the same as a 1 out of 4 chance. So 1/4, 1 out of 4 is the probability of getting Mercury or Venus. And remember, that is theoretical probability. To find the experimental probability, we'd have to actually reach in and draw out some names, maybe 20, 30, 40, 50, 100 times, and see what the actual probability was, the actual experimental probability was. Let's look at an example of experimental probability. After receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probability as a percent. So we're looking at experimental probability because they've done the experiment, they've done the work to see how many times it actually happens. Now the number of ways that the thing we want occurs is what we want to do first. And what we want, or what has been specified to us, is that it has no defects. So how many times did they get no defects? They got it 992 times out of a total of 1,000 times. So that's our probability, but it asks us to write the probability as a percent. So we'll need to punch that into our calculator. We get 0.992, and of course we knew that because we simply moved the decimal point 3 spaces over. We want to write that as a percent. So in order to write it as a percent, we're going to take the decimal point, we're going to move it over 99.2%, or if you want to think of it better, we could round it to about 99%. So that's the probability of getting a skateboard with no defects. Now, it is possible we've got a 0.8% of getting a skateboard with defects, so that's important to remember too. And the number of ways that we get the opposite of our expected event, so in this case, the number of ways that we get one with defects, so this was no defects, the number of ways to get one with defects was 1,000 minus 992, so that was 8 ways out of 1,000, and that is called the complement. This is the complement of this, right? Because together they add up to give 1,000. So that would be 0.008, which is not quite even 1%. So that's how complements work. Last example of experimental probability, you asked 500 randomly selected households in your town if they have a dog. Of the 500 households, 197 respond that they do have a dog. So that's our experimental probability. 197 do have a dog out of 500. That's my experimental probability. If your town has 24,800 households, about how many households are likely to have a dog? Now we can solve this with a proportion, right? We could set this up as something over 24,800, right? So the total number of households, 24,800, under the number of households that have dogs, and we can solve that. So we get 500x is equal to, and then we multiply 197 times 24,800, and we get 4,885,600, and then we would simply divide on both sides by 500, right? So we can do it that way, and that's going to give us x is equal to 9,771.2 households. So approximately 9,771 households. Now I could just as easily have done it like this. I could have simply found the probability of this, 197 divided by 500. Okay, so I know the probability is 0.394 or 39.4%, and then just multiply that by 24,800. And that would give my answer, 9,771.2, or just about 9,771 households. That's it. All about probability. The next video will tell you a little bit more about some different kinds of probability problems.